Hello, we're back with example 4. Now I want to talk about the domain range. The domain is what's really important here. With the domain, we have what's called an agreement on the domain. When you're given an equation and it doesn't specifically tell you what the domain is, you're going to assume that the domain is all real numbers that give you a real range value. Now let's look at B for an example of this. B doesn't tell me anything that it doesn't tell me what the domain should be. Therefore, I start with assuming that it is all real numbers. In other words, negative infinity to infinity. However, because it's an even radical, in other words, a square root in this case, I can't use every number in the real number system. And the reason why is if I plug in, let's say, -4 in for the x. Well, 2 times -4 is -8. -8 minus 1 is -9. So -4 for my x would give me not just 3, but 3i. And that's a problem, because we want to be working in the real number system. Therefore, I can't use this -4. So you have to ask yourself, what would give you, or what would actually limit your domain? What we're going to talk about, at least in this chapter, are 3 types of functions. You will see polynomial functions, and A is an example of a polynomial function. You will see like B, where B is a rational function, a radical function, not rational. And you will see E, which is a rational function. Okay. Now, A, B, and E, well, A is polynomial. Anytime you have a polynomial function, in other words, you have y equals some polynomial degree expression. In other words, in this case, it's y equals x plus 4 in degree 1, which means it's a linear function. So A, your domain, is going to be all real numbers, because there's nothing that you can plug in to this equation that will give you a non-real y value. B, however, as you've already seen, is not that case. Radical and rational equations limit your domain. So let's talk about radicals. At least even radicals. Because if they're odd radicals, like the cube root of something, like if it was the cube root of -8, that would give me -2, not -2i, just -2. Therefore, an even radical makes it to where you limit your domain. And to do that, you have to ask yourself, well, let's just take this. When is y going to be a real number? Well, what's the lowest value you can take the square root of without using an I? The answer there is 0. Therefore, anything underneath the radical, it's called the radicand, so square root radicand. Whatever is underneath, in this case, must be greater than or equal to 0. Because I can take the square root of 0. It is 0. So go up here to B. I'm looking at y equals the square root of 2x minus 1. So whatever is underneath the radical, 2x minus 1, must be greater than or equal to 0. And then, of course, I solve for x. Add 1, which gives me 2x is greater than or equal to 1. Divide by 2. So x is greater than or equal to 1/2. Then all you have to do is put this into interval notation. So your domain here, you're going to the right, which means on the number line, you start at the 1/2 and you go to the right. So you are going to include it because we have or equal to here, because you can take the square root of 0. So you start out at 1/2 and you go to infinity. Now let's look at e. E, the domain, comes from your denominator. It's all real numbers except where you might be dividing by 0. You always have to take into account the possibility of dividing by 0. So for your rational, you're going to assume that it is all real numbers, but then whatever's underneath, in this case x minus 1, your denominator can never equal 0. So your denominator not equal to 0. So in this case it's going to be x minus 1 not equal to 0. Solve for x, which means that x is not equal to 1. So on the number line, if you need to see it, 1 can be right there, which means I can use everything to the left of 1 and I can use everything to the right of 1. I just can't use 1 either that way or that way. So I have to use parentheses for both of them. And this is how you take out a single number from a number line. So your domain is everything to the left of 1, which is negative infinity to 1, and it's everything to the right of 1, which means that it's 1 to infinity. And don't forget, we need to combine this into a single answer using this union. So your domain is going to be negative infinity to 1 union 1 to infinity. Notice I haven't looked at C or D here. I'm just going to tell you C is actually a parabola opening towards the right instead of up or down. So because of this, C actually has your domain to be 0 to infinity. We're not going to worry about the range here. And D, well, when you have an inequality, just replace your inequality with an equal sign and figure out what your domain would be then. So for this, if it's equal to x minus 1, then that means that this is a polynomial equation, or in this case inequality. So your domain is going to be all real numbers. So polynomials, all real numbers. For an even radical, whatever's underneath the radical, called the radicand, must be greater than or equal to 0. And for the rational, your denominator cannot equal 0. So in other words, that can't equal 0. That is your domain. I will talk about the range real quick. I'm not going to do much with the range because we'll come back to it later on. On A, because it's a line, it is negative infinity to infinity. B, because it's a radical, it starts at 0 and goes up to infinity. We'll come back to why later on. It'll be in section 7. C, again, if you look at this graph here, it goes up that way and down that way, which means your range is actually negative infinity to infinity. D, well, it's just if it's a line, then the line would have all real numbers, negative infinity to infinity. And E, well, I'm not even going to tell you why, but the range is going to be negative infinity to 0 union 0 to infinity. And the reason I'm not going to tell you now is because we'll need a lot of time to talk about this, and this will be in chapter 3, section 5. And that's where you'll learn how to find the range of this.